Good morning, all. Welcome to PhD program in wireless sensor networks along with IoT and its applications. So today we'll discuss about the concept of wireless sensor network and its applications in this lecture one. So basically, a sensor is we can call this as a transducer, which will convert a physical phenomena into electrical signals. The physical phenomena in the sense which may be the heat, light, motion or vibration and sound. It has to wait for the event to occur, and when the event has occurred, it has to sense. So a sensor node is nothing but which is a basic unit of sensor network which will contains onboard sensors as well as the processor, memory, transceiver and power supply. So all these components together we can call a sensor node. When we come to sensor network, it will consisting of large number of sensor nodes and the nodes deployed either inside or very close to the sensed phenomena. Where we are going to sense that we need to deploy that. So these are the content we are going to discuss about. And when we deploy the sensor node, these collection of sensing devices which can be communicate wirelessly, and these sensor nodes collectively form a network which is called a wireless sensor network. And we know that which will consisting of large number of sensor nodes deployed in a particular area. Based on the area, we need to deploy that corresponding number of sensors. If the area is small, a small number of sensors required. If you want to cover more area, then we need to deploy the corresponding. We need to increase the corresponding number of sensors also. So which can be a node can be capable of communicating with each other, the neighboring nodes. The if we consider one node, that has to be communicate with all its neighboring nodes in that particular network. Because of this short range transmission range, as we said now, more number of sensors are required to cover that particular area. And basically, there are two types of sensor are there. We can classify that as stationary sensor networks as well as the mobile sensor networks. When a particular class of networks where the nodes are sensor nodes, the nodes which have the capability of sensing the physical phenomena that occur around that region. Wireless sensor networks are key to the formation of Internet of Things, that is IoT, and along with IoT and wireless sensor networks are very important components for building smart things or like smart cities. A particular sensor node might be able to sense the temperature or which will sense the pressure, which can be used to sense if there is any object that is moving around them, and which can able to sense the colors or which can able to sense the vibration occurring around them and sense whether there are any sound around that particular sensors. So based on these categories, we will divide that into two classes. One is called stationary sensor network and the second one is called mobile sensor network. So whereas stationary sensor network, once the sensor was deployed, the sensor will not move in that particular network. In the case of mobile sensor network, the sensor nodes may move in that particular network. So when we consider a particular node, it may have a various subsystems called sensor subsystem, processing subsystem, and communication subsystem. In sensor subsystem, which will be able to sense the event to occur, and the processing subsystem, once the event was sensed, it has to processed. Then after processing, the communications subsystem can be able to transfer that particular message to its neighbors. The basic advantage of that particular sensor network is the design has to be robust, and it should support the reliable communication, and it has to have the concept of accurate, that is sensing networks covering the wider region, and fault tolerant, That is, many nodes are sensing the same event. Usually, there are two main operations which are performed by that particular sensor node. One is called data dissemination, and the second one is called data gathering. The dissemination, in the sense, the propagation of data or the queries throughout that particular network. In the case of data gathering, the collection of observed data from the individual sensor nodes to that particular sink. That means a sink is a node which can be which you can call as simply it will gather the information in that particular region, or simply you can call it as custom. So in that particular node hardware, as we said, there are subsystems called sensor subsystem, processing subsystem, as well as communication subsystem. As we said, as we know, the sensor is having very limited capacity. Like in the case of memory, we can have up to 128 KB to 1 MB. Now, when we consider the advanced sensors, the memory size may be more, little bit more, but still we need to there is a need of improving that memory to store the large amount of data. The sensor subsystem is having 66% of total cost required for supervision only, because the sensors will not always sense the data, but the sensor has to wait for the event to occur. Once the event is occurred, it will sense that particular event. The battery is also very limited battery, and the processor is having 10 megahertz, which will perform very slow computations. And the transceiver, that is to transmit as well as receive it, we need to have 300, that is 1 kbps to 1 mbps, and the range is in between 3 to 100 meters. And due to wireless concept, we may have lossy transmissions. So these are the some sample sensor nodes which can have. And when we consider the wireless sensor network, it should provide distributed network and internet access to sensors, as well as controls and processors that deeply embedded in equipment, facilities, and that depending on that particular environment. The network is a new monitoring and the control capability for applications in transportation, as well as manufacturing, healthcare, environmental monitoring, and in case of safety also, it also includes security. So it will combine the micro sensor technology, which is having low signal processing, low power computation, and low cost wireless network capability in the compact systems. So wireless, this technology has announced by the House Science Committee as one of the nation's technology breakthrough. The great advances in scientific discovery during 105th Congress on September 24th in 1998. So when we are going to design a sensor network, we need to consider several constraints, like they have very short transmission ranges. Because of the size of that particular node, the capability of each of these nodes are very limited. A node like computer, they have an operating system also. Consequently, the batteries also have very limited lifetime because of the small in size, and which is the size may be less than cubic centimeter. So most of the sensors will consume less power, which can be operated in highly dense area, and these nodes should be autonomous, because when you are going to deploy a particular sensor, at the time of deployment only human intervention is required. Once the node was deployed, there is no need of any human intervention. It should be act as an autonomous node, and in communication as well as in transmitting the data. At the same time, the node which is going to be deployed, that should be adapt to that particular environment. So it has a low cost also. When we consider the applications, the sensor network is used in mostly military applications, which can be used to monitor the surveillance of that the movement of the equipment, as well as movement of the personals. And by this sensor network, we can easily target that particular opponent person. And we can be used in nuclear, biological, as well as chemical attack detection. We can also use in environmental applications like forest fire detection and biocomplexity mapping of environment. Flood detection also we can use in agriculture as well as water pollution and air pollution. These sensors can be nowadays it becomes passionate to have the sensor networks in healthcare. That is, which can be used in telemonitoring and tracking as well as monitoring of doctors and patients inside the hospital, along with drug administration. As we know, now the homes are building in smart way. So for that we need to have sensors. So to create smart environment or to automate that particular house, we need to have various kinds of sensors. So with these sensors, let us assume that in a particular smart home, when we are entering into one room, I want to switch on the light as well as air conditioner automatically. So the job of the sensor is to wait for the sense. That means wait for until the person is entered into that particular room. Once the movement of person has occurred in that particular room, the sensor will sense that movement of that particular person. Then it will give sense to that corresponding device so that lights and air conditioner will be operated, will be switched on. And when we are coming out, automatically these two will be switched off. Automotive applications also we can use. So it will reduce the effects of that particular wiring and inside the chambers as well as rotating parts. And let us assume one simple example. I think everybody knows Prince Diana. So she met with an accident uh, when she is traveling in a car. At that time, the car was fully automated, driverless car. Even though the driver was there, at one particular point of time, the sensor in that particular car is unable to sense the bridge or the simple canal. So due to that, at the speed of 120, the car was crashed with that particular bridge. So she died in spot itself. Sometimes the sensors maybe become faulty based on the situation as well as the condition. So in future, every smart home and smart office will be enabled with the help of sensor network, which can be used in biomedical as well as medical applications also, and industrial as well as commercial applications also. Now they are using sensors in most of the vehicles as well as most of the industrial applications. And we can also use the traffic management as well as monitoring with the help of sensors, which can be able to sense the traffic flows as well as real-time route updates, which will be used to handle the thefts as well as accidents. So we can have the other commercial applications with the help of sensor networks. The environmental control in office buildings, interactive museums. For example, when we enter into a museum, when we want to study about or when you want to know about that one particular item in that particular museum, so when we reach to that corresponding item, immediately the sensor has to sense and it will give the corresponding information about that particular item to the visitor. Inventory console also possible, vehicle tracking and detection as we said previously. And humidity level, temperature measurement, lighting condition, air pressure, soil makeup, noise level, vibration. In these cases also, we can have the wireless sensor networks. Let us have some small look on that the existing network sensor networking projects. So the famous one is which is implemented in Kenya, that is called ZebraNet project. They want to know the movement of zebras. So what they did is they simply deployed sensors in each and on each and every zebra. So by that they can monitor, they can able to monitor the movement of zebra. And we can also have the deploy the sensors in underwater. which can be able to communicate very efficiently. And another real-time example is vineyard. So imagine smart farmlands where literally every plant will have its own sensor. Let us assume that, making sure that it get exactly the right nutrients, exactly the right watering. Imagine the impact it have on the difficult areas of the world of agriculture purposes. So usually the in case of Intel, it believes that somebody or some on particular moment, billions of embedded chips and sensing devices will be integrated into objects, and the locations that are part of our daily lives, like clothes, baby, or cars, swimming pools, office buildings, hospitals, even vineyards, as well as the farms. So another example is called habitat monitoring. So if you want to know what kind of birds are available in that particular region, so what we need to do, we need to have one camera as well as microphone along with the sensors. The sensor will sense when the bird sound happen. So it will the microphone has to collect the sound of that particular bird. Then when the microphone collected the sound, the sensor has to sense the camera. So the camera will be clicked so that we can able to know what kind of birds are roaming in that particular region. And there are some common challenges like scalability, quality of service, emergency efficiency, security, and limited storage and computation, limited bandwidth, and the error rates are high, survivability in harsh environments. We know the scalability is nothing but providing acceptable level of service in the presence of the large number of nodes. When we comes to quality of service, it has to offer the quality of service parameters when we deploy the sensor network. The quality of service parameters in the sense bandwidth, delay, jitter, packet loss, or some other quality of service parameters of that any network. So because of this limited bandwidth, we can not possible to predict the changes in radio frequency channel characteristics. Energy efficiency, the node have should utilize the energy in efficient manner. As the security, it is an open medium. Nodes prone to malicious, it may be possibility of getting malicious attacks and eavesdropping interference. When we comes to design challenges, heterogeneity, we may have the various kinds of devices, not the similar kind of sensors. We may have various kinds of sensors based on the region or based on the situation. It is possible to deploy various kinds of sensors. So when we deploy various kinds of sensors, they should have the capability to communicate with each other and to collaborate with each other. So the distributed processing is nothing but we need to have a specific algorithms to be centralized as the processing is carried out on the different nodes which are deployed. Low bandwidth communication. The data should be transferred efficiently between the sensors. That means the deployed sensor should consume or should be operated at low bandwidth levels also. So when the sensor need to be coordinated with each other to produce the required results when large number of sensors are deployed, then in that case we need to have large scale coordination. And in the case of utilization, the sensor should be utilized in a way that it will produce the maximum performance and it has to use very less energy, limited energy. The computation should be done quickly as new data is always being generated. That is called real time computation. Always it has to generate new data and the generated new data has to be processed or transmitted. So let us have some comparison of the cellular network and ad hoc network. As we all know, no need to go in deep. So we can say that simply the cellular network is a fixed structure and the ad hoc network is infrastructureless. And cellular networks, we have a guaranteed bandwidth, but in the case of in the ad hoc network, we cannot guarantee any fixed bandwidth. In the case of cellular network, centralized routing, ad hoc network, distributed routing. In cellular, circuit switched network we are using, and in ad hoc network, packet switched network we are using. Like there are some differences you can easily observe. In the case of the wireless sensor networks and ad hoc networks, again some kind of differences are there in between wireless sensor network and ad hoc network. So when the nodes are communicate with others with the help of intermediate nodes, then the intermediate nodes acts as a relay node, because when the source and destination are in that particular communication region, no need of any interference or no need of any mediator. But if the source is outside the range of destination, then it has to depend on the intermediate nodes. Then the intermediate nodes will be acted as a relay nodes. In this case, sometimes the node may or may not be cooperating with each other, because sometimes the node may become selfish node based on the various characteristics. Either it may cooperate or it may not cooperate. When the one of the reason for non-cooperative node is battery power. When battery backup becomes low, then it may become the selfish node. Otherwise, it will be acting as a cooperative node. So the types of node behavior. Usually, the node is a normal node, misbehaving node, as we said now. It may be cooperative node or non-cooperative node. So normal means everything is okay, which will be cooperative. That is, which will work perfectly in ideal environment conditions. In the case of misbehaving node, we have unintentional as well as intentional nodes. So it says unintentional means unfortunately the node may become selfish node, or the node may not in a position to cooperate with each other because of various reasons, because of network disconnectivity, because of power backup, because of some other reasons. It may become non-cooperative without any specific reason. In the case of intentionally it is not cooperating with each other. By knowingly, it is not cooperating with each other. So in unintentional, there are two kinds of node behavior we can find. One is called failed and the second one is called badly failed. Failed node in the sense which will simply those who are unable to perform an operation. This may be because of power failure or environmental conditions. It may become the failed node. Badly failed node in the sense it will having the features of all the features what we have in failed node. Along with that, it will also send the false routing information in that particular network. We can treat that as a badly failed node. In the case of intentional, the selfish node is the which we can have unwillingness. Okay, unwillingness to cooperate, as the protocol requires wherever there are personal cost involved or packet dropping is the main attack by that particular selfish node. Malicious node, the another kind of intentional node behavior, so which will aim to deliberately disturb the correct operations of the routing protocol, denying the network service. Like these kind of behaviors we can observe in particular sensor. So when we come to microsensor network technology, which will give a significant impact on 21st century lives, and which will be ranges from millimeter to inch, very small in size. Because of this very small in size, the limitations also uh, when we compare with ordinary sensor node, the limitations are very limited resources we have for that micro sensor network technology. But in this case also, if you want to cover more area, then we need to have more number of sensors. The characteristics of when we consider the characteristics of wireless sensor network, as it is low power, limited memory, and energy constraints due to the small in size. So these wireless sensor networks are also deployed extreme environmental conditions and may be prone to enemy attacks. So even though these nodes are deployed in ad hoc manner, they need to be self-organized and self-healing, and it can face constant recognition. And when we come to issues and challenges in designing the sensor network, so these sensor usually when if you want to deploy in dense environments, it is not possible to go physically and deploy the sensor. So what they will do, if we consider deep forest, it is not possible to go and deploy the sensors inside the forest. So what they will do is randomly they will throw the sensors from the plane or other resources. So when they deployed randomly, they do not require any human intervention once the deployment was done. So setup and maintenance of the network should be entirely autonomous. They need to maintain themselves, they need to coordinate with the neighboring nodes, and they need to farm a particular network. So these are the main issues and challenges when we are designing the sensor network. But when we are designing a sensor network, we need to consider the standards. As these wireless sensor networks, when we are deploying, that should follow IEEE standard, which is 802.15.4, which is meant for low rate wireless personal area network. So low rate solution with multi year battery life and very low complexity. It intended to operate in unlicensed international frequency band. So we should also consider this one. And the physical and MAC layer specifications of sensor and other like other wireless personal area networks. Low power consumption is an important feature targeted by this particular standard. This is 802.15.4. This requires reduced transmission rate, power efficient modulation techniques, and strict power management techniques such as sleep modes. So there are other standards also like SenseIT project by DARPA, which focuses on large distributed military systems. So when we come to the simulation tools for this sensor networks, there are various kinds of simulation tools based on the requirement. We may use any one of these simulation tools. There are Sense, SSFnet, Glomosym, MSP WSNet, and Castelia, Manasim, and OPNet. These are the various simulation tools we can specifically meant for wireless sensor network, and there are some other tools also. So even though the wireless sensor network is not that much the current area, but in future when we combine with wireless sensor networks with IoT, it may become the hot topic in future. Every uh, construction and every automobile industry and everywhere in every application areas, we are going to integrate wireless sensor network with IoT. So still there is a scope in advancements of wireless sensor networks along with IoT, like unnamed autonomous aerial vehicle technologies in wireless sensor networks and infrastructures for energy data collection and analysis in networked manufacturing plants, energy optimization, especially in heterogeneous networks. There are some localization problems and there are improving routing performances, and there are we need to have some advances in deployment technique. Whatever the techniques we are following, we need to improve that deployment techniques. And still, there is a scope in healthcare applications, body area networks, and in case of security, IoT applications, etc. Thank you.